I've recently picked up a couple more robots that are a little more powerful than my other ones. So we need a more sturdy base. First thing is to get rid of those rickety legs that aren't stable at all, and bolt the tabletop directly to the riser that's holding my bigger robot. To do this, I'm going to have to build another leg to add on to the base. So now I should be able to run as fast as I want without having to worry about it going anywhere. So we have a fast robot, but that doesn't mean anything if we don't have a fast way to feed it. I found this old video of a robot system that has a similar infeed system to what I was looking for. It takes a handful of dominoes and then outputs a row of singulated dominoes. So I built a similar mechanism that's a tube that has an auger on the inside to pull dominoes out from this bin. I built a prototype, but no matter how much testing I did, I just could not get mine to work the same as the one in the video I saw. And me just wanting to focus on the robot part of the project, I really didn't give this much more thought and just started feeding the system by hand. But one other thing I wanted to focus on in this project was to use a machine learning model to detect and prevent jams. So on the infeed belt there are 3 kickers that are controlled by a computer, and that computer has a web camera that's looking in front of all those kickers, and if it sees a domino that could jam the downstream system, it will kick it off the belt and return it back to the feeder. This could be a domino on edge on top of another domino, or one at a 90-degree angle. Turns out placing dominoes at high speeds is actually pretty difficult, and the reasoning for this actually comes down to a lot of physics. The dominoes I'm working with are toppling dominoes. They're solid, injection molded, and they don't absorb any kinetic energy. They bounce better than a bouncy ball, which we'll find later on that this makes handling the dominoes very difficult. At first I struggled to place 10 or 20 in a row without them toppling over. Initially this was due to how I was picking the domino. They were consistently not parallel with the table. So instead of just pulling directly off the suction cup, I 3D printed some part squares that go on the gripper. So when the robot goes to pick a domino, they get squared up with these brackets that are parallel with the table. But even though the domino was exactly the position we wanted it, there was still an invisible force that would occasionally knock over the domino. Moving at these high speeds, the robot is ever so slightly shaking, and occasionally that will hit the domino, and since it doesn't absorb any kinetic energy, it just completely knocks itself over. To fix this, I programmed the robot to release and move back from the domino at the precise time to not move the domino at all. But I'm sure from this footage you can immediately see the next problem. The robot arm is shaking the table the dominoes are sitting on, which isn't a problem at first, but the longer the dominoes are on the table, the more they start to walk around. So to isolate the vibration in between the robot and the domino, I put this really thick rubber mat on the table, and this absorbs a lot of the vibrations and gives the domino more grip. So then I went to test it. First I adjusted the place height and then I tested it, and with that we can now seamlessly place dominoes at high speeds without them walking around or toppling over. With Robot 1 placing the dominoes pretty seamlessly, now it's time to get Robot 2 involved. And there were a couple issues with the first run, but I still wanted to touch it up so that we could see all 500 dominoes fall. This video is sponsored by PCBWay. PCBWay is an online custom manufacturing service that makes PCB boards, does PCB board assembly, 3D printing, and CNC machining. PCBWay makes it easy to upload custom PCB files, and they'll give you an instant quote. Their services can be cost-effective for low-volume hobbyist makers all the way up to industrial production. Go to PCBWay.com to take advantage of their many special deals and coupons they're running for the month of January for being in service for 10 years. For 10 years, PCBWay has been making crazy, awesome projects possible for people like me and businesses all around the globe. So once again, thank you to PCBWay for making this video possible. And then I made a couple more attempts at making a perfect run. And made more adjustments and tried again. After making more adjustments until finally I got a perfect run, 500 dominoes in a row without a single issue. Thanks again to PCBWay for sponsoring this video, and don't forget to subscribe and like the video if you liked it. I had a lot of fun with it, and all the CAD and code is linked in the description below.